Okay, sorry, I was having a little bit of technical difficulties there. Okay, I'm gonna go back over here. Hopefully I won't have the same issue again. Okay, I think I had to, all right, I had to click and kind of hold on that thing. Sorry about that. All right, so here we go. The chi-square distribution, it was 27.59, okay, was the X value. Degrees of freedom were 17, okay, and cumulative, yes. Oops, yes. Okay, minus chi-square distribution. Chi-square distribution. I had to kind of click and hold. Okay, I'm sorry, guys. I'm learning. Okay, 27.596.408. 17 degrees of freedom. 17 degrees of freedom. Cumulative, yes. Okay, and I hit enter and I get 94%. 94. Okay, 94%. So let's go over here to the iPad again, and we'll kind of write that down. Okay. Okay, 0.94, 0.94. Okay, so there's that. Okay, what were the other things they wanted us to figure out? Well, they wanted us to figure out what is the chi-squared sub 0.95 thing? Yes. What is chi-squared sub 0.95 with 17 degrees of freedom? Okay. Well, okay, so we come over here, and that means, so chi-squared 0.95 with 17 degrees of freedom satisfies that 0.95 is equal to the probability that X is greater than or equal to this thing. Chi-squared 0.95 of 17. Okay, where X is distributed as chi-squared of 17, of course. So I have to find a number that does this, right? Once again, we have this chi-squared distribution. This guy right here satisfies, okay, so that's not what this one would look like, actually. Let me erase that. Okay, so a 95%, of course, right? So that means that this stuff right here would be 0.95. And this guy right here would be chi-squared 0.95 of 17. Okay, that's what we're looking for. Okay, so we want the percentage beyond this point to be 95%. 95%. So how in the world would we find that? Well, it turns out we can use Excel to our advantage again. Okay. Okay, so let's go over here. Watch this. So here's Excel. Hopefully I don't mess this up again. Okay, so equals, watch this. Okay, type chi-square. Okay. And what you can do is you can say, okay, inverse, so chi-squared, look at this. Chi-squared inverse right tail returns the inverse of the right-tailed probability of the chi-square distribution. That means it will tell you the number beyond which you get a certain percentage, okay? So what do we have here? Let me click on this. So what probability do I want to the right of this? Well, I want 0.95. It's very carefully telling you it's talking about the right tail. And what about degrees of freedom? Well, 17 in this case. And I get 8.67176. Now, 8.67176. Now watch this, just to kind of make sure that this thing works. Watch. The probability that X is less than or equal to, or is less than 8.67176. This should be equal to 0.05, right? Because the probability that X is beyond this is 95%. Is it? Let's check that out. So we go equals the chi-squared distribution. Okay. What's our x value? 8 point, okay, so I want to put it right here. Okay. What's the degrees of freedom? 17. And cumulative, yes. We should get 0.05. And we do. Hallelujah. Right? So 8.67176 is what we get for this thing. 8.67176. So let's go over here. We'll kind of record that. Okay. And we'll move on to the next thing. Okay. So this guy, chi-squared, let me just kind of erase this. Chi-squared, no, actually down here I have it written down. Chi-squared 0.95, 0.95 with 17 degrees of freedom. This is equal to 8.67, 8.67 basically. 8.67576, is that what it was? 8.67176 rather. 8.67176 rather, okay? 8.67176, okay? And going on to the next one, so first of all, so that's what we get for that. What else did they want us to find? They want us to find chi-squared of 0.025 with 17 degrees of freedom. Chi-squared of 0.025 with 17 degrees of freedom. Well, so let me remind you there, so what do I want? So x is still distributed as chi-squared with 17 degrees of freedom. We want 0.025 to be equal to the probability that x is greater than or equal to this number. So this is chi-squared 0.025 with 17. Okay, so what is this? Okay, in this case, it kind of looks like this. Okay, 0.025. So this guy really is going to be up here a ways, right? And we want there to be 0.025 probability in the right tail. So this is chi-squared 0.025 of 17. So what is this going to be equal to? Well, we're going to use our handy dandy Excel to pull this off. Okay, so what do? We go equals chi-square, inverse right tail, right? Inverse, the distribution would give us a probability. The inverse takes a probability and gives us a value. Okay, so chi-squared inverse right tail. Okay, so probability, this time in the right tail, we want 0.025, degrees of freedom, 17, and we get 30.191. 30.191. And just to check, right? So we could just to check ourselves, we go chi-square distribution, what's x? Well, x is this, degrees of freedom, 17, and cumulative distribution function, 1. Now, what should this be when I hit enter? Think about it. 30.191, that means there's 2.025, 2.5% to the right of that. So that means it should be 0.975. And it is 0.975. Okay, so let us go back to our iPad screen and we will finish this off. Okay, there it is. Okay, so it was 39. It was 39.191. 39.19 or 30, or sorry, not 39. 30.191. Yeah, 30.191. Okay, 30.191. 30.191. There it is. Okay, so that's how that distribution works, how the chi-square distribution works, and how some of these other things happen to work. I think I'm basically going to leave it at that for now. Well, maybe Yeah, I think I'm going to leave it at that for now because this is getting rather lengthy. We'll finish up a couple of things with the chi-squared and exponential and gamma distribution. We'll move into the normal distribution next time, okay? But hopefully that was a worthwhile exploration, and we'll talk to each other soon. Bye for now.